solving right triangles. When we say that, we actually mean something. So to solve a right triangle, you need a certain minimum amount of information about the triangle. And this triangle shown below has two pieces of relevant information. So what are those? Well, the relevant information are side lengths and angles. So we need to have side lengths and angles. And in a triangle, we have three of these, three side lengths, and we have three angles. I'm going to change colors here. Is there enough information to find the length of the hypotenuse? So this is the hypotenuse. Change this line. Thin, I like thin. This side here doesn't have a name unless we choose an angle, and we don't know either of these two angles. We do know they're complementary angles. They will add up to 90 degrees. We know that this is opposite this angle and that this side is adjacent to this angle. But if we think about SOHCAHTOA, any of the ratios, as a matter of fact, any of these ratios involve three quantities: one angle, two sides. The information we have here, we have one angle, which really isn't of any use to us in here, only for finding the hypotenuse, and we have one side. So we don't have enough information to find the hypotenuse, because if this was the side opposite this angle, then we could say, well, we've got opposite, but we don't know hypotenuse, we don't know the angle, so we cannot solve for this. So is there enough information to find the length of the hypotenuse? No. Is there enough information to find the length of the other leg? No. Is there enough information to find the measure of the other two angles in the triangle? No. We just don't know enough here, right? In any of these formulas involving three quantities, angle and two sides, we need two pieces of information. If we have these two sides, we can find the angle. If we have the angle on this side, we can find that side, and so on. Okay, so let's move on. Let's see what we're going to do here. So to solve a right triangle, and solving, the specific meaning of solving is find the lengths of all the sides. How many? 3. And the measurements of all the angles. And there's 3 of those. So when we say solve a triangle, you're going to end up with 6 pieces of information, but you're going to have to know some of those already. Right, and being as we're working with right triangles, we already know one of the angles is a right angle. That's one piece. Here we have 2, here we have 3. So to solve this with 2 sides, we'll find the third side and we'll find these 2 angles. Okay. So if we have 2 sides, what can we do? Well, we can use the Pythagorean theorem to find the third side. And then we can use these 2 angles to find one of these angles, this one or this one. And then once we have the 2 angles, we can use the fact that these are complementary angles to find the third angle. Or what else can we have to solve a triangle? We have one side and one acute angle. If we have this side and we have this angle, well then, you know what? We know this angle, or we'll calculate it very quickly, and then we can calculate the remaining 2 sides to solve the triangle, which means we'll know that all 6 measurements. Okay, so let's take a look at this guy here, which is this one from up here. So let's call this little a. So remember naming conventions. Angles are named with uppercase letters. The sides, we use the lowercase letter of the angle, which is opposite. So this is angle C. This will be side C. In this triangle, we know that a squared plus c squared is equal to b squared. We know b, it's a we want to find, so a little bit of rearrangement. B squared minus c squared. let's fill in values. A squared is equal to, we know b, so 19 squared minus 14 squared. A squared will equal, let's get out a calculator, just turned itself off, let's clear this so we can start fresh. 19 squared minus 14 squared is 165. A squared is 165. A is the square root of 165. This is an exact value, okay, and it's important that we recognize that, and that sometimes we'll be using exact values, and we want the square root of that. So let me show you how to do that on the calculator. We go second function x squared, that brings me square root. I want this number. To get the number, I go second function, and then see this little a and s, so on the minus here, and a and s means bring down the previous number. So it's going to bring in the 165, and we get, rounded to the nearest tenth, 12.8. Are there units involved? Yeah, seeing as there are units in the original triangle, then there are units here, and we bring in units as the last step. So A is 12.8 centimeters. We now have 1, 2, 3, the three sides. We have one angle. We need to get these other two angles. Okay, let's say that I want to find, angle A. Now, it's best that we don't use a calculated value, right? So we're not going to use this. So we're going to stick with B and C in relation to angle A. This is adjacent, and this is, well, regardless of angle A, this is just the hypotenuse. So now we think, all right, I have adjacent hypotenuse, which ratio? That's cosine. Let's write down a formula. The cosine of angle A is adjacent over hypotenuse. The cosine of angle A is 14 over 19. I want to do an angle, so you got to remember back a few days. So A is the inverse cosine of the ratio. So we have the ratio, we want the angle. A is the inverse cosine of the ratio, 14 over 19. Okay, so second function, cos inverse 14 divided by 19, close bracket, enter, 42.5, we want nearest tenth, so 42.5, A is equal to 42.5 degrees. Now, we could have worked with angle C, in which case this would be opposite. If I had worked with angle C, I would have said the sine of angle C, sine is defined as opposite over hypotenuse. Sine, C is my unknown, right? But we do know opposite, which is 14 over 19. So angle C would be the inverse sine of 14 over 19, which is second inverse sine, 14 divided by 19, close parenthesis, enter, 47 point, and we're rounding to the nearest tenth, so we look at the 6, we round this up, 47.5 degrees. Okay, did we have to do both this and this? No. One or the other would have been fine, since we know that these angles are complementary. They must add to 90 degrees. Had I calculated angle A, I would simply have said angle C is equal to 90 degrees minus angle A, which is equal, let's move this down a bit, which is 90 degrees minus 42.5 degrees, which is 47.5 degrees. Or again, if we had, right, oops, we only have to do one or the other. If I had calculated angle C, I would have said angle A is equal to 90 degrees minus angle C, which is 90 degrees minus 47.5 degrees, or 42.5 degrees. At this point, we should have 6 measurements, right? So let's just summarize this all. We have side A is 12.8 centimeters. That was calculated. Side B is 19 centimeters. Side C is 14 centimeters. Angle A is 42.5 degrees. Angle B is 90 degrees. I want to squeeze this in. Angle C is 47.5 degrees. That's 6 measurements, 3 sides, 3 angles. This solves triangle example number 1. Example 2. Now you'll notice in example 2, we're not giving you a diagram. It says solve triangle PQR, and there's information. So what we're going to do is we are going to draw our own diagram. So it's a right triangle. And the diagrams generally, I say especially the way I draw them, diagrams are placeholders for information is all. So this is my 90-degree angle. That corresponds to angle Q. So that's Q. That makes this side here little q. P is 35 degrees. I'm going to put that down here. Label this 35 degrees. This side is opposite angle P. That's little p. Leaving this as r. And this guy here is little r, which is 8 to 85 inches. So there's our diagram. And so if you're not provided with a diagram, draw a picture. It gives you an idea of what you're looking at. To solve this triangle, well, okay, if you're ever given a triangle where you've got one of the acute angles, it's a right triangle, we know these two angles here, P and R, have to add to 90 degrees. So angle R is equal to 90 degrees minus angle P, which is 90 degrees minus 35 degrees, which is 55 degrees. So at this point, we now have all 3 angles. Okay, what do we need? Well, we need 2 sides. We need to find little p and we need to find little q. So what have we got? We could use either angle R or angle P since these are exact, but let's go with the numbers that we were given. So we're going to go with P, we're going to go with R. So in relation to P, this side is opposite. This, well, in relation to anything, this is the hypotenuse. And in relation to P, this is adjacent. So let's use opposite and adjacent and the 35-degree angle. That's the tangent ratio then. So it's not like we have to squeeze things in. So the tan of angle P, formula, opposite over adjacent. Okay, substitution, the tan of 35 degrees is opposite, which is little p, over adjacent, which is 85. Want to solve for little p, we're going to multiply both sides. So p is 85 times the tan of 35 degrees. Let's turn it off. 85, tan, 35, enter, 59.5. Okay, and again, we'll just round to the nearest. It should really say, let's go, we'll go to 2. So let's do 59.52. If this were a test or anything, then we would really make sure that we said what you were rounding to. 59.52 inches. Now, keep in mind, this is a calculated value. So we're going to try and avoid using it if we can, which means we're just going to go from scratch and we're going to say, all right, I want to figure out hypotenuse. I have adjacent. We'll go back to these 2 values. It's the cosine ratio then. So cos of P is adjacent over hypotenuse. Okay, so we have two pieces of information, right? We have angle P, we have the adjacent side. Given those two, we can solve for the third. So cos 35 degrees is adjacent, which is 85 over, in this case, little q. Remember how you solve these, right? The quick way is just to interchange these two. We're going to multiply both sides by q. That will give you q cos 35 is 85, and then divide both sides by, okay, so it would give you q cos 35 degrees, okay? We don't put units on here, but we must always put degrees, is equal to 85, but don't need that. The quick way is just to interchange these two and go q is equal to 85, excuse me, divided by the cos of 35 degrees, right? That's the line that follows from this line I crossed out, right? You multiply both sides by q, then you divide both sides by cos 35. So q is 85 divided by cos 35. And that's 103.76. Look to the right, that's a 5, so 103.77. 3.77, and now we need units, the side length inches. So what measurements do we have? One side, two side, three side, one angle, two angle, three angles, right? We have all three angles, we have all three sides. That's what it means to solve a triangle. And we can do that in under 17 minutes.